In today's video, we'll break down two crucial HVAC measurements, superheat and subcooling, and why they're key for performance, troubleshooting, and preventing breakdowns. Many in the trade mention them, but few truly understand their importance. Mastering these measurements can set a good technician apart from a great one. We'll start with simple explanations, then show how they apply in real systems. What is superheat? Think about heating water. At first, the water temperature rises until it reaches its boiling point, which is 100 degrees Celsius, 212 degrees Fahrenheit, at sea level. At this temperature, water begins turning into vapor. If you keep adding heat after it reaches the boiling point, the vapor temperature rises above 100 degrees Celsius. This additional heat is what we call superheat, the heat added beyond the boiling point while the substance is in the vapor phase. Formula for superheat. Superheat equals current vapor temperature minus boiling point, saturation temperature. Example, if the vapor temperature is 109 degrees Celsius and the boiling point is 100 degrees Celsius, the superheat is 9 degrees Celsius. In HVAC systems, superheat occurs in the evaporator. The refrigerant absorbs heat from the indoor air, evaporates into vapor, and, if designed correctly, leaves the evaporator slightly above its boiling point. Why that matters? It ensures all refrigerant entering the compressor is vapor. It prevents liquid slugging, which can destroy the compressor. It provides a diagnostic tool. Too much superheat can mean low refrigerant charge or restricted flow. Too little can mean flooding back to the compressor. In residential air conditioning, a typical target superheat is around 8 to 12 degrees Fahrenheit, 4 to 7 degrees Celsius, for a fixed orifice system under normal conditions. What is subcooling? Subcooling is the reverse concept. It refers to cooling a liquid below its condensation temperature. When refrigerant vapor is cooled in the condenser, it reaches the condensation point and changes into a liquid. If we continue cooling this liquid refrigerant below its saturation temperature, that temperature drop is called subcooling. Formula for subcooling. Subcooling equals condensation temperature minus current liquid temperature. For example, if the condensation temperature is 100 degrees Celsius and the current liquid temperature is 80 degrees Celsius, the subcooling is 20 degrees Celsius. In HVAC systems, subcooling happens in the condenser. Why that matters? Ensures the refrigerant reaching the expansion valve is 100% liquid. Prevents flash gas before the metering device, improving efficiency. Helps diagnose issues. Low subcooling can mean undercharge or inefficient condenser. High subcooling can indicate overcharge or restricted liquid line. In most modern systems, a healthy subcooling range is typically 8 to 15 degrees Fahrenheit, 4 to 8 degrees Celsius, depending on manufacturer guidelines. Superheat in the HVAC cycle. In the refrigeration cycle, the compressor can only compress vapor. If liquid enters, it can cause mechanical damage because liquids cannot be compressed. This is why proper superheat is so important. The evaporator must convert all refrigerant into vapor before it reaches the compressor, and then add a little extra heat to ensure it's fully vaporized. Technicians measure superheat by measuring the refrigerant temperature at the evaporator outlet, finding the saturation temperature for the refrigerant at the current evaporator pressure, using a pressure temperature chart or digital gauge. Subtracting saturation temperature from actual outlet temperature. Subcooling in the HVAC cycle. In the condenser, the opposite happens. The refrigerant exits the compressor as a superheated vapor and is cooled down until it condenses into liquid. After all vapor has turned to liquid, we want a few extra degrees of cooling. This is subcooling. Proper subcooling ensures that no vapor enters the expansion valve. Cooling performance stays consistent. The system avoids loss of efficiency caused by premature refrigerant boiling. Technicians measure subcooling by measuring the liquid line temperature at the condenser outlet, finding the saturation temperature for the refrigerant at the current condenser pressure, subtracting the actual liquid temperature from the saturation temperature. Key diagnostic insights: low superheat plus low subcooling, Possible undercharge or restricted airflow across the evaporator. High superheat plus low subcooling. Likely refrigerant undercharge or restriction before the evaporator. Low superheat plus high subcooling. Possible overcharge or restricted airflow across the condenser. Knowing these patterns can save hours of guesswork during service calls. To summarize, superheat means vapor heated above boiling point. It occurs in the evaporator and protects the compressor. Subcooling means liquid cooled below condensation point. It occurs in the condenser and ensures full liquid to the expansion valve. Both are critical measurements for efficiency, reliability, and accurate troubleshooting. By mastering these two concepts, you'll not only improve your diagnostic skills, but also extend the lifespan of HVAC systems you work on.